Hello, I'm back and yeah, ready to go. Just jumping straight into the action, I guess. Just had some sports. Yeah, now I'm back, freshly showered and ready to go. My cats are playing on the ground right now. But yeah, we might not see them again in the stream today. But I activated some tools for them, so they don't just get to do the same stuff again and again. Actually, there's a ball between my legs right now, which is not a joke. It's a ball for cats, and it's rotating and trying to roll by itself. Unfortunately, the ball that I was holding in my hand right now is not rolling that well. I got another ball though, and that is rolling much better than the other one. So, and there's quite a quality difference between my two balls. For the cat balls, of course. It's but you only find out that stuff once you buy that, and I'm really disappointed in the first ball. The second one really rolls all over the place through the whole room, and the kids really love to chase it until it gets stuck somewhere. And the other ball basically can't roll more than 1 meter, and then it just dies. Just a little bit awkward. Yeah, okay. If I want to make a cat stream, I would need a cat cam again. Let's keep coding. So we first need to make a plan here in Adobe. Yes, and we need to make a good plan this time, because what we were doing, we were trying different stuff, but nothing. And here we go again. So my USB hub just did reset itself. I will have to unplug my cam, plug it in again. I really have to reset my cam. It's a little bit annoying. That's happening way too often. And I'm losing too much time for this shit. So first I'm going to use my laptop cam. Now I can switch to my real cam. Hope that is working. Ooh. So I got a problem with the audio right now. It doesn't sound right. Let's play the next song and see what happens. Well, this sound is now broken. Okay, I have to restart OBS. So BRB. Okay, here I'm back again. Immediately with some chaos. Still have to find the solution for the cam. Still not using my cam. To try the solution again. Okay, here I'm back. So I think one problem was my headphones had no battery anymore. They have to recharge. Unfortunately. Do I recharge them actually? Yeah, I'm currently recharging them. So I use these headphones. Are they headphones? Earplugs, and I just noticed how horrible the sound quality is. Back in the day, I didn't notice that, and yeah, I just now realized that I always have been used to bad quality. There's a cat toy right underneath me. Wait a second. Okay, it's rolling here all over the place. It's probably going to get stuck in 5 minutes anyway. So the cat toys, they have this efficiency. It's annoying. Yeah, whatever. Well, it is what it is. I can't change it. So my USB hub, all my USB things did reset again. That's probably it's because it tries to connect to Stream Deck via USB cable via a USB hub, and then it tries to use that as a monitor, and I have to unplug Stream Deck now, which is very unfortunate because I was really looking forward to using that too. So now I have to reset the camera. Well, it's still a technical stream, so I can justify this is quite fitting to the topic. Technical problems. That's why you're here. Who cares for gaming? We want to see real problems, like plugging stuff in and out. So, okay, let's try to start, and if we run into an issue again, we're probably hacked. But I'm pretty sure I'm already hacked because I'm on Windows. I have no confidence in that whatsoever. So, let's say here's the mouse position. Mouse pause 00. And then we no. Don't make that new need something. I'm really confused about the sound quality. In my ears, the sound quality is obnoxiously bad. That's irritating. I really need to check this with my headphones again or something. Hey Miri. Oh, I just Oh, we just have a stream with bad audio quality. Whatever. Whatever. I'm not here to enjoy. I'm here for coding and suffering. So it doesn't matter. So we have this offset point. And everything is kind of laggy right now. This is also something, it doesn't matter how fast your engine, your PC is, it's always going to be kind of laggy once you try to do stuff. Which is really annoying. So here we have this, let's write more text. We have the, now this is the mouse position. Let's say this is 2 to the right, 1 to the left. This is the origin. And then this point is the offset. And this would be something like 1 to the right, 4 top. Yeah. I would say 3 top. It's just a rough estimate right now. And then what we have here is we have this rectangle, and it looks like we have a 90 degrees angle here inside, but we don't. That's just by coincidence. At this point, the mouse position could be here, could be here. It's not a 90 degrees point. What we do have, however, is this. We have these two. Then we do have a 90 degrees. What do we know about this rectangle? We know, let's call this A, B, C, H, P, Q. Okay, so what's PQ? We'll find out. That's pretty much a formula. And P and Q, I think that they are this, P and Q. P is this part of the rectangle, Q is this part, H is the height. Yeah, H is the height. And now we know everything we need. So, what is known is all the outside is known. We know the 3 positions here. We know those 3. We know A, B, C. They are unknown. We know all the 3 points, and we search for this point. This is the point that we are looking for, and we don't know its coordinates. It's going, I would say it's something like 0, 5, 0, 5, 2. Something like that. It would be something like that. And let's call that point, I don't know what the name of the point would be. And to calculate the point, we need P. We need P or Q. The best way would be, we know P, we go P, distance, in direction, origin, offset. That's pretty much finished. Yeah? And we don't know PQH. But we can calculate these. And now the question is, how do we do this? There's two ways. I could just look up formulas, and I also have some code which does that. So first let's just look at the code. Maybe it's easier to just copy some code if I already have this working. I know the player does this. Let's look into aim. So here's something. No. Let's look at player input. That's a pretty useless class. Where is that? Okay, looks like I once started something and stopped or some. The fuck? As a control, how is it called? Let's look at the player. Yeah, there's a lot of things that have player in its name. There's the player, and the input is, where's the input class? It's user controller thing. Yeah, it's not a good class name, to be honest. It was once used in a tutorial, and I know that inside of here we do calculate this direction. Yeah, and let's just copy this, copy this, and put it into the time map functions, and then try to make this work. So this is in the offset function, and we want to have this calculate aiming direction. What a way we name this to say calculate what would be a good description? Calculate rotated offset point. Okay, and now all we need to do is to look at what does this do. It has a target position. That would be the target position. I think this is the mouse position. Then we have point B and point P. Huh. Ah, yeah, this one had a point P, and point P was here. It always calculate this point P. Okay. Then I would, I think, do this. Yeah. So point P is the mouse position. So let's redo this. We need to name our points here. Be careful. Okay. I think it's is this A? I think this is A. Let's use another color. A, B, C. They are also known A, B, C. Actually, lowercase A, B, C are not known, but they are easy to calculate. It's just that we know them very well. So, point C. And I'm looking at point C. Oh, in the end, this is going to calculate point C. Okay. The aim line must. Let's read that comment. The aim line, and also. The mouse position is going to be point B. Point A is the offset point. And point C is the origin. So we then calculate, so we have A, B, C. We then just calculate A, B, C. This also has the formula for PQH. That's very useful for us. So B is the distance from point B to point C. Point B to point C, yeah. C is the distance from point B to point A. From point B to point A is going to be C. We did a mistake there. Yeah, okay. So we made a mistake there. The lowercase letters are always at the other side. So this is C, this is B. Whoopsie. Yeah. Yeah. So from point B to point A, B to A is going to be C. Okay. And A, we actually don't need to use the binomial formula. This is going to be A. Oh, A is over here. A is B to C. But B is C to A. What the fuck? is 8, these two, then B and C. And I think it's always like this, so this vector was wrong. What the fuck? That's irritating. Let's look again. B is the distance from point A to C. Point C. C is the distance from B to A. A is the distance from B to C. Yeah, okay. So I don't know. The formula in here was wrong, and I'm using this in the game. But it works there. Maybe there was a case where they had the same length or so. Maybe. Then it would be... And I didn't know the other point. Then it would be possible. Because there was a point missing in here. I think we didn't know point C. Ah, okay. And then it could make sense that we don't use... that we use another formula here. Okay. This is also searching for point C, yeah? We already know point C. We are looking for point P. Yeah, we are looking for P. So, no, P is... It's A times 2 divided by C, and then we don't need anything else. Let's just comment these two out. We don't need them. Oh, and this point is called point H. We have to... So I don't know what point P is, but this is point big H. So point direction B to A. Okay, this was calculating from another point. We calculate from C to A. C to A. And then we get point H. And we return that. Yeah, and for the rest of this, we don't care. We just let this be in here if we can't get the correct point. So let's just plug it in here and see if we can get this to work. Make this static, and here we go. You should immediately see a result when we try to use this function. So damn it. That's not correct. It has a quite weird behavior. It's like it has its own AI. Unfortunately, I'm not that impressed. Let's look into our problem again. So we have the origin. Origin should be point C. Point B is the mouse. Point A is the offset. That is correct. Let me calculate ABC. Let's look if this is, if we need to use P or Q. I'm not that sure here. But also, why do we use point B here? I want to look from point C, so this is a, and let's use Q. Now let's use P. Sorry, I can't decide. Yeah, there already was a mistake that I saw this, so let's just see if that fixed it. No, not really. So here it is just way too big to be either P or Q. Okay, let's just look into the graph again. So this says it's divided by C, but I'm not sure. Maybe we need to divide by B. Let's look into trigonometry. H, P, Q, math. Oh, come on. Triangle. Come on, find something. Yay. Can you maybe also give me some formula? Okay, I'm not sure. So this is what I'm looking for, but I'm looking for the solution. So, oh, it's on Wikipedia. In Wikipedia, it's basically you can go fuck yourself if you want to understand it. Like, it's like Wikipedia is really one of the worst places to look for an explanation. I don't know. Where is this used? And you normally expect here something like h is what the fuck? Oh. So I took this math just straight out of a book, and I look in here and I see this formula, and I think like, yay, that's very inefficient if I do this. I'm pretty sure there's a better formula for that. Okay. It looks like we are not getting any further here. Let's look where this is used. Where does it use H? H. I don't find the graphic that I just saw. So what the hell? I mean, why do they use the worst formulas for the length of H when there's easier ones, better ones? I don't understand. I'm pretty sure last time I googled this I did find good examples eventually how to calculate H. Triangle. Calculate H. It's let's just see. So where did I use this inside of here? And then there B and A were different. We looked at it, tried to find another H. I don't know. So let's look at this graph again. So here we have C. So A divided by B, maybe? A divided by B. That would be the one that makes most sense. So the direction is right now. Look at this again. Okay, I'm just going to get my old mathematics book. And because I know there's a formula in there that is working. It's a book, something that is unknown in these type of days. It's just a good book. They write in formulas that you actually can use. And I don't know why, but the formulas in here are just much better than what I just found on Wikipedia. And I'm not going to use formulas which are not as good if I don't need to. And here it is. It's hard to read. It's about here. No, it's really hard to read. So this is talking about exactly this problem. So I'm not now here in my chair like a granddaddy. And what's in there is so they first of all they flipped the whole chart. So they use A and C. So our triangle is flipped, so it's a little bit annoying. But you're not annoying, you're lovely. So no, the second one has to be B. I'm just not sure if you have to use P or Q. Let's try this with Q. But I'm not very positive about that. No. Also not the correct distance. So now we get to the point where we check everything from the start to the end again and again. So A is the offset point. B is the mouse position. C is the origin. Small. Wait. Let's also reorder these. Small a is C to B. B to C, okay, doesn't matter. B is A to C. C is A to B. B to A. Yeah, that works. So far, okay, everything in here is alright until we get to the point. We want to see, we search for P. Oh wait, there's a problem. Oh, I see the problem. Oh no, I see the problem. This only works if this has a 90 degrees angle. Kill me. Oh no. Oh no. Oh no. We can't use these formulas. We can't use these formulas. Okay. So far so good. Okay. So what we do have is ABC and all the distances though. And we still search for H. We just have to take into we have to stop this. Because this doesn't exist. There is no PQH if this doesn't have a 90 degree angle. Well, there is, but then the formulas are different. But we can use simpler formulas. Or just do all these small baby steps so we in the end know what we are doing. Okay, then let's try to recalculate. Cables. Let's try to recalculate. I never thought I would sit here with a book and try to do math. It's a little bit unfortunate that I can't get my second camera to work anymore. Since Yeah, I don't know, some kind of drivers said that it can't support USB hubs anymore. Really a shame. So let's at least find the formula of today. And this cable. It's really annoying. Holy shit, I will swap to my normal headphones. The sound quality is so horrible. Really, I don't know how it's like night and day, and back in the day, a year ago, I was really used to this sound quality. It's really obnoxious. Yeah, I will switch my headphones. Just because I can. I hope the other ones are loaded right now. But I can't keep working like that. On the other side, can't keep working like this. I have to stop distracting myself too much. Yeah, and now the quality is way better. So really have to give Quarter credit for the headphones. They're really good. Like one of the best headphones on the market right now. When I got these headphones, I really realized for the first time what good sound quality is. And it's beautiful. Now let's keep working on this. So we have ABC, ABC. Now we don't have P and Q. Yeah, we don't have those. What we do have however is this. Then we know this is a 90 degrees triangle. This would have H. This would be P. This is H. So let's make that clear. This is point P. This is what we are what we are searching for. Is it point P? I think it is. This is H. And then this is, we look, this is P. This is Q. And we don't know any of these. But we do know A. We only know A. God damn it. It's not like in university where they give you these tasks and you pretty much know that the formulas that you do have are going to find the solution somehow, or else they wouldn't give you this task. But in my case, hey, good luck. we don't know. That's really bad. So let's look at this again. We have this. This is A. This is C. This is B. And we know this is a 90-degree angle. We only have this side. And it doesn't... We know that we won't use this anymore. We also have these two, but we don't need them. We have this vector. We can try to do this with the vector. Okay. But before that, let's see if there's no way in trigonometry that we can use this formula. So we know A. We don't know this side. We don't know this side. Can we get any other side? What did we do here? One of the sides was calculated with the with Pythagoras. Pythagoras. Can we calculate any of these sides with Pythagoras? Only have one side, so that's pretty hard. No, we can't. That's... Damn. It's also always two sides missing. If we don't know any of those lengths to P. Not one of them. If we would know one of them, we don't know this one, we don't know this one, we don't know this one. If we would know any of them, then it would be GG. It would be easy. But we don't. Okay, so we might have to look into vector calculation to do that. So we have this vector CA. This is a vector that points from C to A. We have that. And we know that the vector B to P is CA turned 90 degrees. It's turned 90 degrees in to the left. So I think it's minus 90. Actually don't know. B could be at this side of this surf. So we don't know the sign here. You would have to find that out. We can find that with signed angle. Can find the sign here that we have to use. And then we know B. We know B to P. This would be P. We would know that direction. And then we would have to calculate where those two meet, and then we would have P. So, and B to P is not CA to... Is it? No, it is. That's... Oh, Dino. Sorry that I didn't pay attention. Unfortunately, my speech chat is kind of broken. Let me try to reload it. Yeah, now of course it can reload. Hi Dino. I'm trying obviously some trigonometry. I'm already using. I'm not sure if you are watching, but I'm already using a mathematics books. Oh man. Hi there. I'm already using a book to just get this trigonometry done. So what I'm trying to do is pretty easy. So this is actually the last function that I know I want to do. So I can't say this is the last function, but this is the last function that I know about that I want to have. But I'm pretty sure that this is the last thing that I want. So I want to set the offset here, and I want this offset to have the same distance as the distance that would be from this mouse position until the point where these two lines meet. You see, this is on the line here, and I want the helper point to be like this, yeah. And then you just put your mouse up and down and set the offset like this. Now the problem is I can do this with the distance very, very easily. And I could just use, you could just say, hey, why don't you just use the Y value of the mouse, yeah? I could just use the Y value of the mouse and it would have the correct value, yeah? I could just go anywhere, it would be fine. The problem is this. So this is why I need to use some kind of real trigonometry or vectoring. Yeah, check where's this the position from the mouse going to meet the line between those 2 points. Yeah, and this is where this is all about. So this is the origin, this is the mouse position, this is the offset. And I kind of have to calculate the correct position P. And I first tried just to some Pythagoras, some height value, and some formulas from my mathematics book. But they don't work because I don't have. It's not like in school where you have all the necessary sites. I wanted to use this, and then I was like, oh shit, I'm missing all these sites here, and I can't calculate this with Pythagoras or some other formula, because I don't have enough information to calculate this point with trigonometry alone. Yeah, so also this is not 90 degrees. This is not 90 degrees. So this because the point could be anywhere, yeah? So here, it could be here, then at this point you would have a triangle between the mouse position, the origin and the offset, and it would not be a 90 degrees triangle. Now it would be here. Now this would be 90 degrees, but the mouse can be at any point. This is why my formula is failing, yeah? And I've been trying to construct a 90 degrees angle inside of here. I also have one here. And then I see like, oh shit, I don't know any of these sides. I don't know this point. I don't know this the length of these sides. This side is probably going to come out last. I know the full length of this side, but I don't know how it's scaled. So I'm pretty much left in the dark here. And this is why I'm now trying to somehow figure out one of these points here. Alright, let me do this in red. I need come on, right. This line, this line, this line, or this line. Any of those would help me, or this point. And I don't have any of those. Because if I look at this triangle here, this one, I know C, B, and A. And that's pretty much just one line. I know just one line, and that's not enough information. Yeah, I know this angle here. I don't know this angle. I know this. No, I don't know this angle. I don't know it yet. I know the angle from this point, but I don't. I could calculate all three angles. But then I would still be left in the dark. Yeah, that's kind of annoying. And if I calculate this with angles, it will be... I think it's possible. But it's easier to do this with vectors. I'm a little bit more confident in vectors than in angles. So this is why I'm then trying to do this with vectors. So I'm trying to see... So we have this vector C2A. You know this direction. And B2P is pretty much the same, just turned 90 degrees in one of the sides. Yeah, depending on where B is. So we can get those two. And then, what do we then do? And we have to...
I'm kind of surprised that Vector 2 doesn't have it, but there is Ject.
What the hell did this just get censored? Let me try to decensor this.
If I understand you correctly, you want to project it onto B.
No. if I would... You mean small a? Small a. It's not given that small a here is the same size as this. This could be... You have to take into... you have to look that those two sides can be completely different. So they look similar here in this example, but B could be at any point here. And let me try to make an example where it doesn't fit. Maybe here.
Sure, project would still work.
Like here, these two sides would be completely different. Okay, project. Vector T project.
Their example even projects a longer vector onto a smaller one.
Okay, let's try that out. It sounds promising. But I'm just skeptical because of experience. Every time I've seen something promising lately and it comes from another dev, it has been a disappointment. But except for you, yeah, except for you, most of the time you're completely correct. So let's see, Vector 2 project. Just find reflect, not project.
Bible thumb THX for those words of encouragement.
Yeah, it's really I've too many.
Vector 2 doesn't have it.
Oh, it doesn't have it. So maybe Vector 3. We would be happy if any vector has it. Oh no, my dark mode is not working here probably. So okay, now I have to really focus a little bit. You understand this probably. Just so I don't want to waste your time. Okay, so we have a vector and a normal. Okay. I don't understand. So they have this vector, okay. They know the length on this, and they have this normal, and they know the direction. Yeah. And with the projection, this hits at the same and if you would draw a line here at the top, these two would be in a triangle.
The text actually explains it quite well. It gets you the closest point on the infinite line on normal to vector.
Yeah, okay, that actually is correct. That's exactly what we are looking for. Okay, Projects a vector into another vector. To understand vector projection, imagine that a normal is resting on a line pointing in its direction. Okay, this is the direction. Somewhere along that line will be the nearest point of the tip of vector. Okay. On the tip of vector. So this is like, if this is 0, 0, this would be something like -2, 2. And then you get out 0, 2. And this normal is like 0 0.5. No, 0, 0, 5 or something. If I understand this correctly. Projection is just a normal rescaled so that it reaches the point on that line.
Yeah.
A function will return 0 if on normal is always 0. Okay, sorry if I'm a little bit slow here, but I'm just trying to get this right on the first try. And I just feel like if I read this very carefully, maybe I will be faster afterwards. Yeah, but I think I already got the idea. So let's go back in here again. Oh no! Let's first just go to sketching it. Yeah, let's not start coding before we have the sketch. So, let's make a new sketch. C, B, A. And the vector, so this is the normal. Yeah, this is the normal. C to A. C to A is the normal. This is C to B is the vector. No. B is the vector. I think B is the vector. And this
No, CB is right.
Yeah, in the end we have to use CB because we're looking from world.
Everything is relative to C.
Yeah, no, in the end we have to look from C because we are looking in the world. I'm looking like if C is 0, 0, just for simplification, and then take that into effort. Yeah, it's actually CB. That's correct. Yeah. And then it will project itself to this position, and we just get this out. Okay, that sounds too simple to actually work. It sounds too simple. Okay. So let's just try it out. Where did I code this in though? It's here.
Put out the closest point relative to C, so you gotta add C at the end.
Ah, okay. So, in the end, I would have to add the.
You want the global position that is.
I would have to add this point, the origin. This is the origin point, and then I would have to say vector 3 dot projection. Project, and then what are the points here? So now these 3 are the points. We don't have the vectors yet. We don't have what are we looking for? We don't have C2A and C2B. Now these are very easy vectors, but let's nonetheless put them into this method here. Just say return here. Let's just skip all the parts here. Okay, we have these points. We don't need the distance. Let's try to return here. We will plug in the vector that we are going to return later. It's going to be the transform position of this plus something. And we want to use this here as the position of that point. So we still have we will still have to clean up a lot of things here. There still is this helper point, for example. This is not going to be in the final product, by the way, just to see what we are doing. So we have A, B, C, and I'm going to work with 2 monitors now. But fortunately, I got my OBS set up so it follows my mouse. That's great. So yeah. Actually, my book thrown onto my camera. Whoops. Whoopsie. Okay, now it looks alright. Okay, so we need C2A. Okay. So vector 2 CA is going to be point C minus A, or is it point A minus C? I think it's point A minus C. I think it's point A minus C. If you look at that, then we have the vector CB. And this is point B minus point C. And then we have to just plug those into project. The first one is going to be the vector, the second one the normal. CA is the normal. So this is after the this is the second argument. CB is the first one. Is that correct? Yeah. And yeah, we should be ready to test this out. This is a little bit too fast. I'm skeptical. Oh, come on. It's just working. That's unfair. That's too easy. Does it works? Yeah. But, oh, we still have to test. Does it work when we are rotating?
Kappa.
It works when we are rotating. It's genius. Thank you so much. This is yeah, as I say, this is more help than I have received ages from another programmer. Most of the time at work, people just are good at selling that they have a lot of confidence, but yeah, there's not much behind that. I'm pretty much often surprised that I often just boost their confidence with some kind of words, but then there's nothing behind that, like no real value. They can't do basic calculations, or they always switch their tasks when they can't they don't get on with it. Okay. So what we then take out of there, we don't use that distance anymore. We have this helper point position, and actually later we will make this into a vector, but now what we want to plug in here is the distance from the origin to that point. And that's pretty easy. Float. I think we also already have a distance in here. Wait a second. With this distance, call it helper point distance. Helper point origin distance. So the distance between the this position and this point. And let's plug it in here. Okay. Let's see what happens. Now this should dynamically change the offset. And it does. It does. Look at that. Now we're not finished. Let's rotate. And now we have a nice function to change the offset of all these objects, and we can draw them in. Or maybe we should pick another draw chance, because the draw chance looks to be a little bit high right now. And it's drawing in too many objects. That's way too many trees. It's weird though, because I have this mode enabled, and it should mean that it does not draw in that many trees. Okay. I think the thing was that the tree pick chance has been set to 0, and then it just says go fuck yourself. Yeah. Okay. If you put this pick chance to 0, it will just say no. Okay. Yay. So now we can rotate. We can change the offset on the fly. Let's say we want to this offset. We could just say, hey, I want all these objects to be in the same tile, and it just works. The only thing this message here is popping up too many times. I still haven't found a way to reproduce this, so yeah, that's kind of a bummer. But hey, with making this calculation, now I would have needed at least an hour more for this calculation. So big thank you to Dino. Thank you so much. I just have to clean up the code here. Still a lot of mess in here. And then I have all my functions for my brush. This is the last thing. And after that, it's just finding bugs. Now I don't know any bugs except for that console message. Now it's not in there right now. But yeah. So first of all, we don't need that helper point anymore. That helper point was to find out what we are doing. But I guess it's time to say goodbye. Now all the references to the helper point have to go. And then I have to look at this. This is going to be what we actually need. So there's a lot of things that have become obsolete now, just because I've been trying out some things and I found out that I want to do this differently. Oh, we have the repeated access. Do we ever use the game object though? No, we could just plug in the position. So we don't need the whole point if we just need the position. Okay, this will throw an error. But aside from that, oh, this has to be renamed. New offset distance. I think that's okay. New offset distance. Now, why do we need to calculate this by -1? The distance is always going to be positive. So this if clause, let's make a comment here. If the direction is so the direction will always be positive. However, the offset could change from positive to negative or vice versa. Just to have a description in there. And then let's go in here and just say, just want to plug in the position right away. And that's pretty much the end of trying to make new functions. Okay, and we still get this error. And it's really weird what it's doing. So it's thrown. It's comparing two game objects, and one of them has been destroyed. Yeah, it's so this compare get something that is null. Grid paint targets preferences. Yeah. I think I know what it is. And I just don't like what Unity does here. So this uses a hidden grid and destroys it on disable. But I don't know if it's because of that. I just don't know. Because this hidden grid is one of the target that could possibly in there, and it's going to get destroyed. But I don't know. It's really hard to guess. See. Do we have any information about that array? So no, we know that on disable was called for the grid paint palette window. Maybe that also did disable the brush. Set brush. So I'm pretty sure that that this is due to the destroyed target. This is pretty much screaming it's about that. I still don't get why. That's not the problem. I still don't know how to not destroy this hidden grid. I need it. So here, if I don't destroy that grid, there will be multiple hidden grids inside of this. So I don't need to care about this, to be honest, but okay. It still tried to access something that has been destroyed. I don't know, maybe this will come up even because it has saved a hidden grid that has been created and then destroyed. Let's... I don't know. Yeah, maybe we have to reopen Unity. That's a little bit weird though. That's very sus what's happening. So Unity is just trying to compare things that have been destroyed, and it fails to check if those objects exist before it's trying to check them. And now I have to kind of see what I can do about that. It's not a lot, to be honest. So here this error is not going to come up. And it's not going to come up until I maybe change something in the code. go inside of here, is it then going to recompile and say error? No. Yeah. And that's why I hate this line of code. I can't really reproduce it. It's really hard. So yeah, maybe let's just leave it like this for a while and see if this destruction of the hidden grid is commented out. If this maybe is going to not let this ever pop up again. I'm still not sure about that. Okay. So now we have this inside of here. Oh, there's one case. What if I let's pick this select. I'm just trying to get all the edge cases. What if all the layer offsets are put to 0 from the start? Yeah, which is, by the way, not unrealistic. Sometimes you don't want an offset. Yeah, and actually these can be auto-generated with a function. And now these offsets are put to 0. Now change the offset. Nothing's happening. Because it's trying to calculate everything times 0. Okay. So inside of the game object brush, we need to write a case. What if everything is 0? Oh, come on, let's collapse everything and just look into the wide field of regions. It still have to be made into subclasses because I'm annoyed by the regions. That offset point display, I think that's the method that I want to look into. Yeah, it looks for the highest offset, and then we have to say if highest offset is equal to 0. What do we want to do then? And just brute force. And let's just brute force. Brute force that this should not be 0. Where's this called though? Where's this called? Oh, it's actually the wrong one. It's not the one there where I want to brute force this. I want to find that one that is called by the parallax time editor functions class, which by the way has a way too long name. Change offset, I think this is the one. Oh, also trying to divide by 0. I'm surprised. that this even legal. So in that case, we want to actually calculate. We want to start from the 0 and then just go through every layer, the related tile maps. And we want to have the float increase, offset increase by per layer. We want to have a game object related tile map. And then we just want to iterate through them. And why? Because I don't want to set the one at 0. Then we do a for loop. Normally I do for each loops, but in this case I want to do a for loop. And then we have this component which holds the information, and then in there the offset is being displayed as information. We want to change this to be, we can actually start at 0, it doesn't matter, to be I times offset increase per layer. We still have to set this value. So this is going to be the this is going to be the distance divided by the count of timers that we have. So if we have a mouse position of, let's say, 5, and we have 5 layers, it's going to increase the it's going to set itself to 1, and then I think, and then it would be like that doesn't work. And then it would start at 0, and then 1, 2, 3, 4, and not end up at the mouse cursor. No, we would have to say count -1. So if we let's do this with 5 and 6 layers, then it would say distance 5. We have 6 layers, but -1, 5. And then it would say, okay, 0 is going to say 0, 1 is 1, 2 is 2, 3 is 3, 4 is 4, and 5 is 5. And we would end up at 5. Okay. So good. In the theory, does this work? No. Did I save this? I don't think it compiled. Load. Can you compile this, please? No, this doesn't work. So it still doesn't work. Why? Either the increase per layer is not working. The mouse, this distance could be 0. Yeah, let's see if maybe that is the case. Because that would mean we would never reach that point. 0. Just see. Yeah, that's the case. So what did this do? So yeah, the offset point was already at the 0 position. So what about that? Go back to the function that we just created. I think it's still open. No, it isn't. It is. There it is. So the new offset distance is going to be 0 if the origin and the old offset point if this is equal to the origin, and this is not going to do anything. So we need to catch this before we plug it in. So if new offset distance is equal to 0, what do we do then? And it's too late and we just have to shoot ourselves. And we come up with the with a way to handle this. I could just put this to 1 and it will just work. You know what? Let's just plug in 1. It will just bug out in the first frame. We will probably not see that. God damn it! It didn't work. Oh dear. Oh dear. Oh dear. What have we done? It's super laggy now. The layer offset has been set to infinity. That was not my intention. In nearly each layer. Okay. Except for number 0. Ah, okay. If this was 0, it would have returned. Now it isn't, but this increment of the distance still is 0. Okay, we can't have this being 0. So this is going to be this times this. The distance that comes in here times the count of time lapse. So we can't divide by 0. That's not good. I'd never do that. Okay, let's go in here again. And then we saw in the first moment it did flicker, and then it just sets up default values. And it just guesses that's okay, just plug in some values in there so we have a starting point. Yay! Okay, so we handled that case. Can I still rotate this 90 degrees? Yeah, I can. That's cool. That's pretty cool. And it still works. That's cool. That's super cool and useful. Okay. So what is my problem? I mean, I'm searching for something that is not alright. But I can't find anything. Kind of disappointed to have to don't know a problem. But I know it will be quite annoying if I go to bed and then I'm like, hey, you know that one bug in line 159? I know how to fix it. Okay, I'm still trying to think of what is missing. So obviously this is good. What's missing is that we test this out on the one side. It's flickering very close to the origin. But then I can just draw them in. And this is just super useful. And with this, I just draw 6 layers with 1 stroke. Can just do it like that. Now I could also draw it in here at this cliff side, but I don't want to. Yay! Now I should also use the dynamic reference point, but hey, let's not overdo it, surely. What's wrong with me? Why am I not satisfied? Why am I... Let's try to get some errors. Is the picker still working? Yes. Can I delete those? Yes. I just can't believe that this tool is finished. I kind of can't celebrate. I don't know why. I should celebrate this, but I can't. I don't know. It's like I want this hardship. I actually don't want this to be finished. Let's rotate this. Now what I really want, I know what I really want. I want to have a way, I want to go through all of the functions and find all of the bugs that could still be in there. Yeah. That's what I want to do. And then I can relax. Only then. But let's call it a day for now. So, really exciting stuff going on here. So, thanks to Dino, I don't know if you're still listening, but it has been a huge development for the tool. Yeah, it's basically finished. It's just finding bugs. Thank you. It's just, I still have to find bugs, and yeah, I just can't feel happy about finishing the tool if I know there could still be a bug somewhere and I still have to clean up code. So this is still going to come. So I'm not finished with working. So I think if I would celebrate now, it would be like celebrating too early. Yeah, it reminds me of how I celebrated my master degree. I didn't celebrate it. I just cleaned my apartment. Maybe I should learn how to celebrate in some years or so when I'm satisfied with my work or something. But until then, I will have to deal with my own stupidness, and this is going to delay the time until I can celebrate a lot. Thank you for watching, and I'll be back, I don't know, somewhere, when I have time. At least next weekend I will be back, because I just like to have hours of coding time, and when I'm at work I just don't have the time to stream 4 hours. I try every day, but then it's just 1.5 hours, and that's barely enough to open the project. So yeah, that's kind of annoying. I still really have to do more home office, so I don't have to drive to my workplace. Okay, so goodbye now. Have a nice night. Sleep well, or have a nice day. I don't know what time zone you're in, whatever you're going to do now. Have a nice time with it. Goodbye.
Raise your voice. Down and down into the deep. Who knows what we'll find beneath? Diamonds, rubies, gold, and more hidden in the mountain soar. Born underground, suckled from a teeth to stone. Raised in the dark, the safety of our mountain home. Skin made of iron, steel in our bones. To dig and dig makes us free. Come on, brother, sing with me. I'm a dwarf and I'm digging a hole. Diggy, diggy hole. Diggy, diggy hole. I am a dwarf and I'm digging a hole. Diggy, diggy hole. I'm digging a hole. Sunlight will not reach the slow. Dig, dig, in the mind. Never seen the blue moon glow. And down some meat, dump our bellies at the beat, tumble home and fall asleep, dreaming in our mountain keep. Born underground, grown inside a rocky womb, the earth is our cradle, the mountain shall become our tomb. Faces on the battlefield, you will meet your doom. We do not fear what lies beneath, we can never dig too deep. I am a dwarf and I'm digging a hole. Diggy, diggy hole. Diggy, diggy hole. I am a dwarf and I'm digging a hole. Diggy, diggy hole. I'm digging a hole. I am a dwarf and I'm digging a hole. Diggy, diggy hole. Diggy, diggy hole. I am a dwarf and I'm digging a hole. Diggy, diggy hole. I'm digging a hole. Suckled from a teeth to stone, raised in the dark, the safety of our mountain home. Skin made of iron, steel in our bones. To dig and dig makes us free. Come on, brother, sing with me.